Hi everyone. In this video, we are going to learn about algorithm. The agenda of today's video is what is algorithm, what are the different characteristics of algorithm, and how do we measure efficiency of an algorithm. Before going for definition of an algorithm, let us take a real case example like how to prepare a recipe. So for example, how to bake a cake. So to bake a cake, we need some set of ingredients and we need to follow some procedure, and finally we will have the final outcome as cake. So here input is set of ingredients. What are the ingredients? For example, flour, milk, eggs, sugar, etc. And we will be having the procedure. So this procedure is nothing but we have to follow some steps, and procedure is steps to follow. Final outcome is cake. In computer language, this procedure which has some set of instructions called algorithm. So what is algorithm now? So what is algorithm now? A step-by-step procedure to solve a given problem. So before baking a cake, obviously we should be ready with input and we know what is the output, means what we are going to prepare, what we are going to achieve, and what are the steps we have to follow. Similar way, whenever we write an algorithm, we have to be very clear with these three. So what is our input and what is the procedure we have to follow to solve a given problem and what is the output. So based on these three, so what are the three things in an algorithm? So first one is input, second one is output, and the third one is finally the procedure which we follow to solve the given problem. Based on these three, we have some characteristics of an algorithm, means we have to follow some rules to define algorithm. So now let's talk about algorithm characteristics. So first one is input. So algorithm must have either 0 or more inputs. So in our recipe example, to bake a cake, we are having some set of ingredients. This is our input. So like 10 ingredients or 12 ingredients. So we have some set of ingredients. Some cases we might not be having the input at all. Like for example, I am giving a task like print hello world. In this, there is no input. I'm just directly saying that print hello world. So just we have to follow some procedure to print hello world. So the output is printing the hello world, means we should be having hello world on the screen, but we don't have any input. So this kind of cases, we won't be having any input. So this means that the algorithm will always have either 0 or more inputs. The input of the algorithm is well defined. We have a task, we have to sort given numbers. So the task is sort numbers. So we are just saying sort numbers, but how do we give these numbers? Is it in the form of array or is it in the form of list? So this has to be clear. So it has to be well defined, and we have to, the well defined means we have to use some data structure, or we have to give n numbers, n time input we have to give. So the input of the algorithm is well defined. Next one talks about output. So the algorithm must produce some output. It can be either one or more outputs. What we are trying to do, so at the end of the algorithm, we want to achieve something that is called output. So every algorithm will have one or more outputs. So at a time I want to prepare more cakes. So then the output number will be more. And in this case, only one cake we are going to achieve. So similar way, any algorithm will have either one or more number of outputs. Next characteristic is finiteness. So in our recipe example, we have the procedure, means we have some steps to follow. So how many steps do we have? So how many steps do we need to follow? Obviously, there will be some fixed number of steps. So there won't be any infinite number of steps, and then there will be some fixed number of steps to follow. So that means that an algorithm must contain a finite number of steps. So in our recipe example, we are following some steps. So if these are not infinite in nature, then obviously we won't get our outcome as a cake. So the procedure will continue forever and then no one will prepare cake at all. So similar way, every algorithm will contain some finite number of steps. Next one talks about definiteness. Each step of the algorithm is clear. Like in our recipe example, so we are having some steps like step 1, mix the ingredients. But what are the ingredients we have to mix? So we won't be mixing all the ingredients in one shot, right? So we will take some flour and then we will beat the eggs and then we try to mix it in one shot and then later other ingredient. So similar way, every step in the algorithm must be clear. So next characteristics talk about effectiveness. So this talks about effectiveness. Each step of the algorithm must be doable. So to understand about doable, so for example, number divided by 0 is always infinity. So in computer language, we are not able to do this operation at all. So suppose if we are having some step like this, then we won't be able to continue with the other steps. So it means that the step of the algorithm must be doable. So we have to ignore this kind of cases. So now we will talk about how algorithm efficiency is calculated. So whenever we are having a problem, obviously we are having multiple solutions to solve the given problem. For example, sort given array of n numbers. So here input is array of n numbers. Output is sorted array. So our goal is what we have to achieve? We have to sort the given array. So this will be having some procedure. So which is our algorithm? Our algorithm. So this algorithm, we are having multiple algorithms to sort given array, like bubble sort, merge sort, etc. So in bubble sort, the steps which we follow in bubble sort and merge sort obviously different. And you may aware that bubble sort takes order of n square time complexity, whereas merge sort takes order of n log n. So it means with merge sort is faster. So the efficiency of the algorithm is calculated in terms of time complexity and space complexity. So what are the two things? One is time complexity. Second one is space complexity. Time complexity always talks about how much time it has taken to complete the algorithm, means complete the steps which we have defined in the algorithm. So time complexity always talks about how much time it has been taken. Whereas space complexity talks about while doing the procedure, while following the steps, are we taking any extra space? Are we consuming any extra space in memory? So that is called space complexity. So how much memory it has been occupied. A better algorithm always gives better time complexity and space complexity. Sometimes we may achieve better in time complexity, and at the same time we might not be able to achieve in space complexity. Just to mention about data structure, a better data structure gives better time complexity and space complexity. So how this happens, we will learn and understand in further lectures. So this is all about introduction to algorithms. Stay tuned, happy learning.